So now we're going to look at slope fields. So in general, when we're sketching out slope fields, the whole idea is to sketch out the derivatives at each point. So rather than plot each point, we take an xy axes here, right? And I'm going to just go from, actually he's just going from -2 to 2. So -1, -2, +1, +2, +1, +2, -1, -2. And we're going to fill in the derivatives at each of these spots in the square here. Well, so y prime is equal, y prime, which is dy dx, that's the slope, right, is equal to y minus x. So at 0, let's plot it in red. At 0, the slope is 0, okay, because 0, 0, I plug in value 0, 0, that means y prime is 0. So I sketch a little hash line that has a slope 0 here. At 0, 1, where y is 1 and x is 0, this would be 1 minus 0, so the slope is 1. Slope 1 looks like that, because that's an equation with the line slope y equals 1. And then I go up one more, and I'm going to get 2, so it's going to look like that. So slope of 2 is like it goes over 1 and up 2, and that's what that looks like. And then when I go down negative, again, this whole time x is 0, y is going to go to -1. So this is a -1 slope, and then here's a -2 slope. Now let's go to the right. As x increases, it goes negative. So when I'm at 0, 0 minus 1 is -1. Then 0 minus 2 is -2. Then 0 minus -1. So if I plug in -1, 0 into here, I'm going to get +1. And then I get +2. And then let's just get the points here. What happens when I'm at 1, 1? That's 0. And at 2, 2, it's 0. At 1, 2, the slope is 1. And at 2, 1, it's 1 minus 2, it's -1, so it's like that. And then -1, -1 would be 0. -1, +2, that's 2 plus 1, that's 3, so it's going to be super steep. Actually, this one, -1, +1, so that's 1 minus, that's actually 2 here. Like that. And then let's see, -1, -1, that's 0. It's actually 0 whenever x is equal to y. And then -1, -2, that's -1. Then -2, -1, that's +1. Then -2, +1, that's 1 plus 2, that's 3, and then it's like almost vertical here. It's like a slope 4. Something like that. And then +1, you see, it's kind of tedious, but you're just plugging in each of these points. So when I'm at +1, -1, so that's 1 plus 1, that's 2. And then when I increase by x by 1, it goes to 0, I think. So, oh, no. So this is going to be 2. -1 minus 2 is -3. That's actually -3. This should have been negative. Sorry, I'm doing my mental arithmetic backwards. So -1 minus 1 is -2. Like that. And then 1, -2, it's -3, and this is going to be like super steep -4. Okay, so that's what the slope field looks like. It looks kind of like, yeah, looks kind of like that for -1, -2. Okay, do the same thing here. Do 1, 2. 1, 2, 1, 2, 1, 2. Okay. So this is just dependent only on y. So that means they're just gonna. So when x is 0, like the x value doesn't matter. So when y is 0, what's sine of 0? It's 0. Sine of pi. When I go up to 1, sine of pi is also 0. Wait. 0, 0. It's like 0 in all of these points here. So it's zeros all on these points because these are all integers. I'm going to plug in some other points to see. Like, it's not always 0, just at the integer values. Now, what about in between? Okay, because so if I have like half a pi, it's equal to 1 where I'm in like when I'm at positive like pi over 2. So pi over 2, it's 1 here. When I go to like say 1.5 or 3 pi over 2, it goes to -1. So here, negative, positive, and it's just look like that all the way across because it doesn't depend on x, right? So this is a good enough, just approximation of the slope field at these points here. Okay. So here we're going to match the slope field with the given differential equation. I know this this graph might be kind of hard to see. Let me try to make it a little bit bigger. But I think like the contrast didn't come out super well on this picture, so apologies if you can't really see it too well. If you look at the actual PDF solution or the PDF file that has the problems, you can see a little bit better. So one of the things I look for when I'm trying to match things like this is I'm very interested to know where the derivatives are 0. Okay, so like for this graph, the derivatives are 0 everywhere where x equals 0. Oops. Where x equals 0, definitely the slopes are 0. So which one of these gives you zeros at x equals 0? So this could be, so A could be 3, 4, or 5, because when I plug in 0 here, I always have zeros. Now, this one here would have slopes are 0 when x is equal to 1. So I'm looking for one where the slopes, where x is equal to 1, the slopes are always 0. And that looks like this one here. It looks like 0 right along all these points here, right? And so I'm going to say this one is A, because of those 0 points. Now this one has 0 and 0, but this one also has zeros when both x equals 0 and y equals 0. So here x equals 0 is the slopes, and here y equals 0 are also slope 0, because you can't see any like hash marks, you just assume it's horizontal like that. And so I'm going to say this is B. Now this one has derivatives at 0 when x is 0, so definitely looks like when x is 0, slopes are 0. This definitely looks like D. And let's just check this one. This one would have slope 0 when y is 0, and that's like along here. And so this looks like C. So that's how I look at it. You can clearly plug in other points, but obviously the ones where the slopes are 0 are easiest to identify, both graphically and in the equations. Thanks for watching. If you're looking for more examples, go to my website. In there, I have free access to over 400 calculus questions that I solve and I show you step by step. So if you're interested in seeing more, please check out my website.